Morning 170. This is Jake, and I'm going to go over the Fall 15 Midterm 2, Question 9, room rentals. So, the first thing I want to go over is just when I read the problem, I should kind of have an idea about which of the algorithms we've learned that I will use. And so, while it does kind of tell me to use dynamic programming, I just kind of want to go over how I would come to the conclusion if they hadn't given me a hint, which sometimes they do not. So, of the algorithms we've learned, the only ones that are, kind of gonna be relevant are, linear programming, max flow, dynamic programming, and possibly greedy algorithms, right? And if we look at the question here, you have two rooms to rent out, they're end customers. We could kind of knock out max flow. It really just doesn't make too much sense here. And at the same time, we can also knock out linear programming because I don't really see any linear constraints to be working with. So that kind of leaves us with greedy or dynamic programming. And if I were to greed here, I would have a hard time kind of proving that I have found the maximum profit. And so that's kind of, those kind of hints just kind of push you towards a dynamic programming solution for this problem, which, makes sense and is why they tell you to do a dynamic programming solution. Now, let's go over part A. So, one of the biggest mistakes on this problem apparently was that people wouldn't give a subproblem when question A asked you for a subproblem. And to put it simply, a subproblem is a smaller version of your problem. You should be finding the max profit over some smaller variables, like less than D or something. And, well, people would write down recurrence relations and such. Don't lose points by putting down the right recurrence relation and not defining your subproblem. It's the saddest way to lose points. So now that we've gone over what a subproblem is, I invite you to just pause the video and think about what the subproblems could be. And yeah. Okay, so I hope you pause the video because we're gonna go over some ideas. And the initial ideas are going to be wrong. You have the solutions. You know what the right one is if you've gone over it. But so some of the ideas that you might start thinking about when you start this problem would be, say, what if I had just one room and it was available for 2D days? That sounds kind of similar. That sounds like, yeah, then I could really just knock this down the knapsack, right? The hint tells us like 2 knapsacks, but you know what? Maybe I could do this with 1 knapsack. Now, there's a problem with that. And the problem is, I can't really stop someone from booking a room that extends past the first D days and goes into the second. Goes into the start of the second room, right? If that's a problem I can't really overcome if I define my subproblem in that way. So that's not what I would consider a great subproblem. Okay, so we're probably gonna have to keep the rooms separate. That's essentially what I've learned from this exercise. So if I keep the rooms separate, and I know that I should probably use 2 knapsacks. Maybe I'll actually just do 2 knapsacks. I'll just keep the room separate and just have 2 recurrence relations. And that sounds like a good idea too, right? I know knapsack, and this should work. But then I think about it again, and, well, we don't want one person booking 2 rooms. In fact, they don't want 2 rooms either. So, again, that's not gonna work, right? If I have 2 just completely separate instances, it's again going to be not, it's gonna miss some parts of the questions that I really need. So if you don't know the solution, I advise that you pause the video, keep these things in mind when you're really solving the solve problem now. That you have to consider both the rooms at the same time, but they have to be kind of separate too. All right, so I hope you thought about this with these hints, and now we could finally move on to the solution. So we want some subproblem. We want to maximize the profit. And for the profit, we want to consider, well, definitely how many days are left in our first room and how many days are left in our second room. That'll keep them separate. I need to keep them, separate but in consideration. Now, what should my final variable be? Again, pause. All right, so now that you've thought about the problem, you'll realize that we have variables for the days, and the only thing we're missing now is considering the customers. So yeah, the customers, customer I, we should think about using the first I, customers. That's the last thing we really need to recurse on. And, well, does this work? Well, that's kind of where part B comes in. They're honestly kind of the same question, but, they split it up in case you mess one up. So, let's think about this. What are the different scenarios in which we could use our subproblem? Well, basically, customer I can take the first room, he can take the second room, or we could just not give him a room at all. And if we're looking for the max profit, that means we want the max. So we want to take the max, excuse the handwriting, we want to take the max of our 3 scenarios. And that would be if customer 1, not 1, but customer I does his thing. Oh man, what is that? 1 second. All right, I found a pen. This is going to be much simpler. So if customer I takes a room, he'll give bid I dollars, and we can find a subproblem. P of there is 1 less customer. He has taken room 1. D1 minus, and how long is he staying? He's staying T of I days. And E didn't touch the second room, right? Want the max of this. The other scenario, as we talked about, being he takes room 2. I don't actually know if this pen improves the handwriting now that I think of it. But it improves the speed for sure. T of I. And the final scenario, if he doesn't take a room, then we don't get his money, and our rooms are not used. But we don't consider him anymore. In all cases, we decrement I. Like, we're done with this customer, right? D1, D2. Oh man, that's pretty ugly, but you have audio. So basically, this problem really just comes down to defining the subproblems. So you have the proper subproblem. The recurrence relation kind of goes with it. The main takeaway is just think about how the subproblems can work, and then just point out little things that how they don't work, and use those to generate a better subproblem that kind of has all your considerations in mind. Like here, we know we had to consider everything at once. We had to consider both rooms at once, but at the same time, we can't combine them into a single variable. And the other tip I have for this is, well, if it says 2 knapsacks, you should probably start thinking about knapsacks. Remember all your dynamic programming examples, honestly, because a lot of the times they will throw a question that will harken back to one of the questions you have already previously examined and learned. All right, thank you for watching, and hope this helped you out.